Okay, before we move on to chapter 10, which is topics in analytic geometry, we need to do a review of completing the square, because we have to use that technique to write the equations in standard form. If you don't have them in standard form, you can't draw them, so it's kind of critical here. So remember what we had with completing the square is we had some quadratic expression, and we were asked to rewrite this quadratic expression in terms of a complete square and a constant. We've used this before to find the zeros. We could find the zeros of this polynomial. So that's one example. We'll go ahead and do that, but you don't actually have to solve for the zeros. You just have to put it in standard form in this case. So we're going to work with, first we're going to work with where we have an even coefficient in front of the x term. That's the easiest thing. Then we'll work with odd numbers. You just have to deal with fractions. And then we'll deal with where we have a constant in front of the x squared term. And then we'll deal with negatives. How you deal with negative numbers. Okay. So the first thing you do is you take the two parts of the equation that involve the variable and you just separate those. So all I've done is put a space here. So you take this coefficient, 4, you divide by 2, and you square it. So 4 divided by 2 is 2, and 2 squared is 4. So we add 4, we subtract 4, and then what we can do is we can rewrite these three terms, the original first two terms and the added term. We could write that as a complete square. So it's going to be x plus or minus something, and it's always what's inside the parentheses here. So in this case it's positive 2. So we add 2, we square it, and then we combine the two constant terms. So that'd be negative 23. So that's how that works. If we wanted to find the zeros of this polynomial, what we would do is we'd move this term to the other side, which we'll end up doing when we deal with ellipses and hyperbolas and parabolas. But we'd also do this if we wanted to solve for x, if we wanted to find the zeros. So we do that, and then you take the square root both sides. Square root of x plus 2 squared is just x plus 2, but when you take the square root of 23, you get plus or minus the square root of 23. And then you would subtract 2 from both sides. So you get negative 2 plus or minus the square root of 23. So those would be the two zeros. This is where we want to get to when it comes to completing the square for analytic geometry. Okay, so that's for an even. So let's do negative 5x plus minus 15 equals 0. So you do the same thing, you end up with a fraction. So first thing we're going to do is we're going to take the two terms that involve x and separate it from the constant term. We take our constant, which is negative 5, divide by 2, and square it. And so when we, so you can't simplify it here. 4 divided by 2 is 2, but here, because it's already a fraction, you can't really simplify it. So we don't have an intermediate step. We just square this, which you get 25 fourths. So you square the numerator. Negative 5 squared is positive 25, and positive 2 squared is 4. So we're going to add 25 fourths, and we're going to subtract 25 fourths. Now, again, these three terms can become a complete square. It's going to be x. Here we have negative 5 halves, so it's negative 5 halves quantity squared. And then over here we're going to have to combine these two terms. So you're going to find a common denominator. So one's a fraction, one's not. So it's easy. You just multiply this by 4. So you get 60/4. And then we can combine the two fractions. So that's negative 25 minus 60. That's negative 85/4. And you can't simplify beyond that in terms of the fraction, because this is odd and those are even. Now we could move this thing to the other side. And again, that's what we're going to end up doing when we deal with ellipses and a hyperbolus. Now if I wanted to solve for the zeros, I'd take the square root of both sides. And so I get plus or minus the square root of 85/4, or plus or minus the square root of 85 divided by 2. And then my zeros would be, if I add 5 halves to both sides, I'd get 5 halves plus or minus the square root of 85 all divided by 2. So that's how you handle odd numbers. Let's do one. What if you had a fraction? Let's say x squared minus 7 halves x minus 10 equals 0. So you take this number again, negative 7 halves, you divide by 2, and you'd square it. So let's go ahead and simplify what's inside the parentheses first. So 7 halves divided by 2 is 7/4. You know, if I made this into a fraction, I took the reciprocal, I'd take 7 times 1 and 2 times 2. And then I'd square that, so I get 49/16. The negative gets squared out. So I'd have x squared minus 7 halves x plus 49/16 minus 49/16 minus 10 equals 0. So these three terms can be written as a complete square using this simplified version. So it's going to be x minus 7/4 squared. And here I would have 10 in terms of sixteenths would be 160/16. So just multiply this by 16 to get 160. So you have 160 minus 49, so that'd be negative 209/16. Again, you really can't simplify that because these are even and this is odd. So again, to get to the point where as far as we need to know for this chapter, x minus 7/4 squared equals that, and then if you wanted to solve for x, you take the square root, so you get plus or minus the square root of 209/16, which would be plus or minus the square root of 209 divided by 4, and then you'd add 7/4, so you get 7/4 plus or minus square root of 209/4 would give you the answer. Okay, we're not getting any more complicated than that. So now the question is, what would I do if, before we put a coefficient in front of x, what if I had a negative? So let's say I have negative x squared plus 6x plus 10 equals something, equals 0. Now, you might say, well, I'm just going to multiply everything by -1, but we need to know how to deal with this negative sign without just dividing or multiplying by -1. So what we do is we'd factor the negative sign out. So you'd have negative times that, but if you factor the negative out of that, you get -6x. So they change sign. When you say factor out a negative, this will become positive, this will become negative. Now we don't do anything with we just put the 10 over here by itself. So we use completing the square inside the parentheses. So we divide it by 2, -6 by 2, which is -3. So that's 9. -3 squared is 9, so we add 9. But you can see what's happening here is I'm really subtracting 9. So once I add this 9, I've got to reflect the negative sign. So I'm really subtracting 9, so I have to add 9. So even though it says plus 9, I'm really subtracting it. Okay. So this becomes, now I can complete the square inside the parentheses, so it becomes negative the quantity x minus 3 squared plus 19 equals 0. Or negative x minus 3 squared equals -19. Now, if I was trying to solve for the zeros, I could divide by -1, but that's but sometimes we don't necessarily need to do that, and you'll see that in some later problems here. So in this case, what we could do is, if we wanted to solve for the zeros, we'd divide everything by -1. You take the square root, so you get plus or minus the square root of 19, and then you'd add 3 to both sides, so you get x is equal to 3 plus or minus the square root of 19. Those would be the zeros of the original equation. Okay, next thing. Let's say we have 4x squared plus 24x minus 40 equals 0. So we still want to group these two terms together, but we're going to, instead of factoring on a negative sign, we're going to factor out a 4. So if factoring, it means you take this and divide by whatever that you're factoring out of. 4 divided by 4 is 1, so that becomes x squared. And we always want to factor it out so this coefficient is 1. So whatever this constant in front of x squared is, that's what we factor out. So 24 divided by 4 is 6. We leave space, and we put the -40 over here. We don't need to factor out 4 for the -40 part. Okay, so we take 6, divide by 2, square it. 6 divided by 2 is 3. 3 squared is 9. So we add 9 inside the parentheses. But you can see we're really adding 36. So we're going to subtract 36 to make everything balance out. So the term in the parentheses is going to be x plus 3. Here's the 3 plus 3 squared. And then we have -76 equals 0. And again, what we need to get to with this equation is to move this to the other side. Now in physics, in calculus, we might want to solve for the 0. So to do that, we divide both sides by 4. And I think you actually can divide 76 by 4. It's going to be 19, because 80 divided by 4 is 20. So 76 divided by 4 must be 19. And then you take the square root plus minus the square root of 19. Subtract 3 from both sides. And that would be your x-intercepts for that original equation. But this is what we're looking for, something like that. And in ellipses and hyperbolas, there usually is some constant out in front of this. So we really need to be good at doing this. So let's do another one. Let's say it's 6x squared minus 25x minus 35 equals 0. Okay, so this one's going to be a little difficult because, for one thing, this number, when we factor out the 6, it's not going to be a nice number. It's just going to be a fraction. So if you divide this by 6, you get 1. You divide that by 6, you get 25 sixths x. Leave a space. Put the constant over here like that. So now what we're going to do is we're going to take 25 sixths, divide by 2. Actually, negative 25 sixths, and divide by 2. So take the reciprocal of this and multiply it. What you'll get is negative 25 twelfths, because you get this becomes 1/2. 1 times 25 is 1. 2 times 6 is 12. And then we still have to square it. I forgot the squared part. So 25 squared is 625. 12 squared is 144. So we're going to add 625 over 144. But what we're really doing is we're adding 6 times 625 over 144. We have to multiply it by 6. And so we should be able to simplify that. If you take 144 divided by 6, so 144 divided by 6 is 24. So I get 625 over 24. These two have a common factor of 6. So that is what I'm adding. I'm adding 625 over 144 times 6. So if I'm adding that, I need to subtract 625 over 24 to balance that out. Now 35 is equal to, we need a denominator of 24. So we take 35 times 24, which is 840. We could simplify that down. If we divide that by 2, we'll get 420 over 12. Divide that by 2, we'll get 210 over 6. Divide that by 2, we'll get 105 over 3. And 105 divided by 3 is 35. So that actually, oh, I already know that. Why did I do that? That was dumb. Okay. Okay, so what we're going to do is we're going to take, we've got negative 625 over 24 minus 640 over 24. So 625, negative 625 minus 840 is 1465 over 24. And I don't think you can simplify that. Let's just try our calculator. 1465 divided by 24. Change that back to a fraction. You get the same number. Okay, so these two added together give you that. So what we end up with is 6. This completing the square will become x minus 25 over 12 quantity squared minus 1465 over 24 equals 0. or 6 times x minus 25 over 12 squared is equal to 1465 over 24. Now I'm not going to solve for x, but that's the key thing here is if you have an odd number to start with and you divide by this coefficient, you're going to still end up with an odd number. There's probably an intermediate level of difficulty where I could have had this, say, equal to 18, and if you factored out 6 out of 18, you'd have 3, and then it wouldn't be quite as crazy a fraction, but you get the idea. Okay, let's say we have a negative now. So we have negative 4. Let's do 3. Negative 3x squared plus 15x plus 12 equals 0. So now we have a negative 3 out in front of x squared. So we factor out the negative 3 out of these two terms. So we get negative 3 factored out of negative 3x squared would be x squared. Here it would be negative 5x. We're going to leave a space and add our 12 over here separately. So you can see I multiply this out. I'll get negative 3x squared plus 15x. So we take negative 5, divide by 2, square it, which becomes 25 over 4. So that's what we add here, plus 25 over 4. Now, what we're actually doing here is we're multiplying negative 3 times 25 over 4, which is negative 75 over 4. 3 times 25 is 75. So we're really subtracting that, so we have to add 75 over 4 here to balance that out. Now this part can be rewritten as a complete square, so we'll have x minus, look what's been squared up here, 5 halves, negative 5 halves. And then here we'd have 75 fourths plus 48 fourths. So change 12 into 48 fourths. Add those together, you'll get 123, I think. 75 plus 48 is 123. So we'll get plus 123 over 4 equals 0. Move this to the other side, negative 123 over 4. So the last couple of examples, we're going to have both x squared and y squared parts. So you just do the same thing, but you have to do it twice. So we're going to start off where we have just a coefficient of 1 in front of x squared and y squared. So you take the x squared plus 6x, separate that from the y squared minus 12y, sorry, that should be a y. And what we're going to do is we're going to move the 20 to the other side. So I'm going to add 20 to both sides. So now we complete the square for these two terms. So we take 6 divided by 2, which is equal to 3 squared, which is 9. So we add 9. Now, because I already have this on the right-hand side, I'm going to go ahead and add 9. Instead of subtracting 9 on this side and then moving it, I'm just going to add it to both sides. Now here we have negative 12, so we have negative 12 divided by 2 squared. So negative 12 divided by 2 is negative 6 squared. That's 36. So we're going to add 36 plus 36. So we can now make this into a complete square. X plus 3 squared is this number, 3, plus y minus 6 squared equals, so we have 20 plus 36 is 56, 56 plus 9 is 65. Okay, so that's as far as we need to go. Ultimately, what we end up doing in so let's just talk about what this is. This is actually a circle. The center of the circle is at -3, 6. So these parts in the completed square give you the x and y coordinates of the center, and the radius is equal to the square root of 65. Circles are x squared. The simplest circles are x squared plus y squared equals r squared, where r is the radius. If you have the center offset, then you have these terms here where you have x plus or minus some number squared. Okay, so let's do 4x squared minus 36x plus 3x squared plus 12x, y, 3y squared, 12y, plus 5 equals 0. So again, what we're going to do is we're going to separate out the two terms that involve x and the ones that involve y. We'll move the 5 to the other side. It becomes -5. Now, just like we did earlier, if you have a coefficient in front of x or y, you're going to factor that out. And to factor it out of both of these terms, you're going to divide them by 4. So 4 divided by 4 is 1. -36 divided by 4 is -9. Here we factor out 3. So we get x squared. 12 divided by 3 is 4. So we get 4y. And that equals -5. So all we've done is factor out these two constants. Now we take the coefficient in front of the x, divide by 2, square it. So that's 81 over 4. So we're going to add 81 fourths. Over here, we take 4 divided by 2, square it. That's 2 squared, which is 4. So we're going to add 4. But what we're doing here effectively is we're adding 4 times 81 over 4. So we're really adding 81 here. And here we're adding 3 times 4. 3 times 4. So that's 12. So we're really adding 12. So to add those, we're going to add 81. And we're going to add 12. So now we can finish it off. So we have the 4. Let me go ahead and put in a different color here, just black. So you have 4, and then you make this a complete square, so it's going to be x. You go back to here, -9/2 squared plus 3 times y minus plus 2 squared, so it's this number, is equal to, so we got 81 plus 12, which is 93. 93 minus 5 is 88. 88. Now, this is not a circle because we have different numbers in front of these expressions. And what the standard form of this is an ellipse, is everything's equal to 1. So what you would do is you would divide both sides by 88. you'd have 4 over 88 times x minus 9 halves squared plus 3 over 88 times y plus 2 squared is equal to 1. So we divide that by 88. Now, as we'll see later, the standard form is we don't want 4 over 88, we want 88 over 4. So we move it to the denominator and take the reciprocal. So it's like when we have this, if we want to rewrite this, we take the reciprocal of this and multiply it out. So you can do the same thing. If you want to move this from the numerator, this was the whole numerator, you want to make that the denominator, you'd flip it around. And the same thing would be true here. So it's actually divided by 88 divided by 3 equals 1. These two numbers here still tell us about the center of the object. So it'd be positive 9.5 comma negative 2. These tell us about the dimensions of the ellipse in terms of which way is it stretched. Okay. Now let's do one where one of them is negative. So let's say we've got 4x squared plus 16x minus 5y squared plus 30y minus 20 equals 0. So we do the same thing. We group these two together and we factor out the 4. So you got to remember, I almost forgot to do it there. Factor the 4 out of this as well. So you divide 16 by 4, you get 4. Leave a space. Here we factor out the negative 5, not just 5, but negative 5. So y squared divided by negative 5 is 1. And you divide 30 by negative 5, which should give you a negative 6y. I need to leave some space. I need to move it over a little bit because I'm running out of space in my screen here. And that's equal to 20. So this negative 20 comes to the right-hand side, becomes positive 20. Now once you've correctly factored this out, you've almost got it figured out. One thing you're going to have to do is when we get this number, we're going to have to multiply by negative 5, but we'll do that when we get to it. Okay, so we take 4, divide by 2, which is 2, square it, that's 4. So we add 4. But what we're really doing is adding 4 times 4, so we're really adding 16, 4 times 4. Over here, we take negative 6 divided by 2 squared. So we have negative 3 squared, which is positive 9. So we add 9. But really, we have negative 5 times 9, which is negative 45. So really subtracting 45. And so we're going to add 16, because I haven't done that yet. And we're going to subtract 45. So this line becomes 4 times the quantity x, and we go to this number 2 plus 2 squared minus 5 times this, which is going to be y minus 3 squared. And then we add all these together, so we got 36 minus 45, which is negative 9. So we're almost there. One thing we would do is we don't want a negative sign over here, so we would divide by negative 9. So you'd have negative 4/9 x plus 2 squared minus 5/9 plus 5/9, because you divide negative by negative, you get positive. Y minus 3 squared is equal to positive 1. And then we would take this and take the reciprocal. So you'd have x plus 2 squared divided by, instead of 4/9, multiplied by 4/9, divide by 9/4. There's a negative sign out in front of this. And then we'd have y minus 3 squared divided by 9/5 equals 1. Now, this is the equation for a hyperbola. When one of them is positive, one of them is negative, it's a hyperbola. Now, hyperbolas either kind of look like this, or they look like this. They're kind of aligned with the y direction or the x direction, and it depends upon which one of these is negative. We'll talk more about that when we get to actually talking about hyperbolas. So I think we've covered all the possibilities. If they're both negative, then you just multiply everything by -1. So we've got the case where we've got both terms, one's positive, one's negative. We've got both terms, both positive. Simplest case is where you have they're both positive and the coefficients in front of x and y are 1. That would be a circle. So anyway, that is those are the examples, and we'll assign one of each at least of these for the homework.